ABGs made simple. ABG stands for arterial blood gases. It measures the amount of pH, which tells how acidic or alkalotic your arterial blood is. It is usually taken from an arterial line or through a puncture. It is not the same as a venous puncture. ABGs measures the amount of different gases like PaCO2 or carbon dioxide, HCO3 or bicarbonate, and the amount of partial pressure of the oxygen and your oxygen saturation known as SaO2. You must understand the basics of ABGs before you can answer ABG questions. The normal value of pH is 7.35 to 7.45. Remember, pH refers to acidity or alkalinity of your blood. When the pH is below 7.35, it is acidic, and when it is above 7.45, it is alkaline. PaCO2 is controlled by our lungs. We breathe out carbon dioxide and breathe in oxygen. The normal value for PaCO2 is 35 to 45. If the number is above 45, it indicates there is more CO2 in the blood, which makes our blood acidic. If the number is less than 35, it indicates our blood is on the alkalotic side. The normal value of HCO3 or bicarbonate is 22 to 26. HCO3 is controlled by the kidneys. If HCO3 is above 26, it means your blood is on the alkalotic side. If the value is less than 22, it means the blood is acidic. Next is your PaO2 or oxygen. This is regulated by our lungs and the normal value is 80 to 100. This simply tells if your patient is hypoxic or not. It is not to interpret whether it is metabolic or respiratory. For blood gas interpretation, you look at the pH value, HCO3, and CO2 value. SaO2 and PaO2 are not needed to determine the alkalosis or acidosis. It simply tells if your patient is hypoxic, but you should know this value. To identify the steps in interpreting blood gases. After identifying whether it is acidosis or alkalosis by looking at the pH, the next step is to check if it is a metabolic or respiratory problem. And then you check if it is compensated or uncompensated. The kidneys and the lungs constantly balancing and adapting to maintain a normal pH level in the blood. CO2 is regulated by the lungs and HCO3 is regulated by the kidney. When the CO2 is not within range, it is a respiratory problem. When the bicarbonate is out of range, it is a metabolic issue. If it is respiratory problem, check if it is respiratory acidosis or respiratory alkalosis. The body will try to compensate by either increasing or decreasing the amount of bicarbonate in the body. This has to be out of the normal range. If it is a respiratory acidosis, the body will compensate by increasing the amount of bicarbonate to neutralize the acid. Remember, bicarbonate is a base and PaCO2 is acidic. If it is respiratory alkalosis, the body will compensate by doing the opposite, that is, decreasing the amount of bicarbonate in the blood. Let's look at this example together. Here we have a pH of 7.56. With a pH of 7.56, it is higher than the normal, which makes it alkalosis. And then we have a CO2 of 47. Then we have HCO3 of 35. Looking at the HCO3 of 35, you know that it is a metabolic problem. So here we have metabolic alkalosis. Then with a CO2 of 47, which is out of normal range, there is a partial compensation because the CO2 is not enough to bring the pH within its normal level. Whether it is metabolic acidosis or metabolic alkalosis, the body will try to compensate by either increasing or decreasing the amount of PaCO2 in the body. This has to be out of the normal range. If it is a metabolic acidosis, the body will compensate by decreasing the amount of PaCO2 in the blood. Remember, PaCO2 is acidic. If it is a metabolic alkalosis, the body will compensate by doing the opposite. That is increasing the amount of PaCO2 in the blood. Let's look at another example. We have here a pH of 7.33. The pH is less than normal, so it is acidosis. We have CO2 of 60. The CO2 of 60 is above normal. So here we are looking at a respiratory problem, which makes it a respiratory acidosis. And we have HCO3 of 47, which is higher than the normal HCO3 level, which shows that there is a compensation. So for this, it is a partial compensation because the level of the HCO3 is not enough to bring the pH within its normal level. So here we have respiratory acidosis, partial compensation. Looking at the tic-tac-toe method. For the tic-tac-toe method, you want to know if it is acidosis or alkalosis. You will look at the pH. To know if it is a respiratory or metabolic problem, you will look at the CO2 or HCO3 level. And then the third step is to identify if it is compensated or uncompensated. Let's look at this example together. Here we have a pH of 7.56, which makes it alkalosis. And then we have a PaCO2 of 27. That shows that there is a respiratory problem, giving it respiratory alkalosis. And then we have HCO3 of 22. Remember, HCO3 of 22 is within the normal range. So this is a respiratory alkalosis uncompensated. Let's look at another example together. We have a pH of 7.31, which makes it acidosis. And then we have a PaCO2 of 42, which is within the normal range. And then we have HCO3 of 20. That shows it is a metabolic acidosis. And then because the PaCO2 is 42, which is within the normal range, there is uncompensation. So that makes it metabolic acidosis uncompensated. Let's look at another example together. Here we have a pH of 7.28, which makes it acidosis. And then we have a PaCO2 of 52, which is acidic. Remember, CO2, increase in CO2 level makes it acidic in the blood. And then we have HCO3 of 31, which shows that it is alkalosis. So here we are dealing with a respiratory problem because of the CO2 level, which gives it respiratory acidosis. And then we have respiratory acidosis partially compensated. We have another example here. If you see a straight line all the way across, just know that it is fully compensated. So we have this example here, pH of 7.43, which is within normal range. And then we have PaCO2 of 49, which is acidosis. And then we have HCO3 of 35, which is alkalosis. So here we are dealing with metabolic alkalosis, but fully compensated because the pH here is within the normal range. The pH lean more on the alkalosis side, and that is why we're saying it is a metabolic alkalosis that is fully compensated. Let's look at this last example together. We have a pH of 7.35, which makes it within the normal range, but it leans more on the acidosis side. Then we have the PaCO2 of 49, which makes it acidosis. And then the HCO3 is 35, which is alkalosis. So because we have a PaCO2 of 49, which is acidosis, we are dealing with a respiratory problem. So here it is respiratory acidosis, but fully compensated. Thank you for listening. Kindly like, subscribe, and share.